Hello everyone, welcome to my channel. I am Rishabh. Today we are going to learn about HDFS implementation and installations. Let's talk about introduction. Introduction. Understanding importance of HDFS, Hadoop Distribution File System (HDFS) is a crucial efficiently storing and managing large dataset across a cluster, enabling big data analytics with stability and fault tolerance. Overview of HDFS, understanding its role in big data. Defining HDFS. The Hadoop Distribution File System (HDFS) is a core component of Hadoop ecosystem, enabling the reliable storing of large datasets across a distributed cluster. Storing large datasets, HDFS efficiently manages data across multiple nodes, ensuring fault tolerance through replication and enabling seamless access to extensive data collection for analysis. Big data analytics. HDFS play a crucial role in big data analytics, providing scalable storage solutions that support complex data processing and analysis take a various industries. HDFS architecture. Understanding the key component of HDFS. The Hadoop distributed file system follow a master-slave architecture with a name node managing metadata and data node storing actual data, ensuring efficient data management and reliability. Master-slave architecture. Understanding HDFS structure and roles. Name node. The name node is the master server that manages metadata and maintains the file name space, crucial for tracking where data is storing across the cluster. Data node. Data node are the slave node responsible for storing actual data block, regularly reporting their status and block information back to the name node for effectively management. Secondary name node. The secondary name node assists in managing the file system by periodically checkpointing metadata, ensuring backup and reducing the risk of data loss in case of name node failure. Secondary name node role. The secondary name node assists in managing metadata, ensuring data integrity, and providing backup for primary node. Data storage. Understanding HDFS data reliable and replication. HDFS store data in block typically 128 MB or 64 MB, ensuring fault tolerance through a default replication factory of 3 across multiple data node in high availability. Data storage. Understanding HDFS data management strategies. Data block. HDFS divide into data block typically sized 128 MB or 64 MB, allowing efficient storage and retrieval across multiple data nodes, enhancing data management flexibility. Replication factor. The default replication factor in HDFS create three copies of each block across different data nodes, ensuring data redundancy and increased fault tolerance in the system. High availability. HDFS ensures high availability for distributing data across various nodes and racks. If a data node fails, HDFS automatically retrieve data from the replicant block on other nodes. Implementation consideration. Key planning steps for successful development. Proper planning for essential for successful HDFS deployment, including assessing hardware requirements, software prerequisites, and ensuring ensuring network configuration meet the demand of your cluster environment. Implementation consideration. Planning for HDFS deployment essential. Hardware requirements. Proper hardware setup include determining cluster size, ensuring your sufficient storage capacity, and addressing network need for optimal HDFS performance. Software prerequisites ensure that your environment meet the software prerequisites, including the correct Java version and compatible compatible and a compatible operating system like Linux for running Hadoop effectively. Network configuration. A reliable network configuration involves using static IPs and ensuring proper host name resolution for the all cluster to maintain seamless communication. Installation steps. Installation steps. A step-by-step guide for HDFS startup. This section outlines the essential steps for installing HDFS on a cluster, ensuring proper configuration and optimal performance for managing large dataset efficiently. Installation steps. Key process for setting up HDFS. Downloading Hadoop. Begin by downloading the latest Hadoop distribution from the official Apache website. Extract the compressed file to your desired installation directory to prepare for configuration. Configuring core site XML. Exit the core site XML file to include essential parameters such as the name node URL. This configuration enables Hadoop to identify the master node for your HDFS setup. Setting up environment variables. To ensure proper execution of Hadoop command, set the Hadoop home and path variable in your system. This allows easy access to Hadoop script for across your cluster environment. Formatting and starting. Prepare the name node. Before launching the cluster, format the name node for initial setup. Start HDFS daemon for enable data storage and manage across data node effectively. Common issues. Troubleshoot tips for HDFS installations. Encountering issues during HDFS installation is common. Understanding common pitfalls like name node startup failure and data node connection problem can facilitate quicker resolution and smoother deployments. Troubleshooting HDFS issues, common problems and their solutions. Name node failure. Name node startup failure can occur due to misconfiguration or memory issue. Examine logos for error messages to identify root cause and adjust configurations accordingly. Data node issue. Connection issue between data node may rise from network misconfiguration. Check static IPs and ensuring host name resolution in properly set up for effective communication. Disk space errors. Insufficient disk space can lead to runtime error. Monitor usage closely and ensure appropriate permissions are set for directories to avoid excessive issues. Replication issues. Understanding the resolution replication issues. Understanding the resolving common errors. Misconfiguration of the replication factor can lead to data loss or reduce availability. Using Hadoop logo and diagnostic command is essential for troubleshooting this issue effectively. Conclusion and summary. This presentation emphasizes the importance of HDFS in big data, its architecture, and practical implementation steps for effective usage. HDFS fundamentals. Understanding the core component of HDFS. Overview of HDFS. The Hadoop distributed file system is crucial for managing vast data HDFS fundamentals. Understanding the core component of HDFS. Overview of HDFS. The Hadoop distributed file system is crucial for managing vast datasets across clusters, ensuring reliable and efficient storage solutions for big data. Master-slave architecture. HDFS employ a master-slave architecture where the name node manages metadata and data node store actual data block, ensuring data availability and system integrity. Data reliability. HDFC achieves data reliable through a replication storing multiple copies of data block across different nodes, thereby providing fault tolerance and high availability even during node failures. Thank you everyone.